Watch NASA's sounding rocket launch from New Mexico. Sun studying mission explained. When you think of space exploration, the mind often drifts to towering rockets blasting off from Florida or Texas. But here's a twist. One of NASA's next missions will take place in the desert landscapes of New Mexico, home to some of the most unique and lesser-known rocket launches on Earth. This is where things get intriguing. On Friday, July 18th, NASA plans to launch a sounding rocket from the White Sands Space Harbor in New Mexico. Located near the Texas border, about 60 miles north of El Paso, this site offers a perfect backdrop for studying parts of space the larger rockets simply can't reach efficiently. Liftoff is scheduled for 1 p.m. local time if conditions remain clear. Residents nearby may even catch a glimpse of the rocket streaking across the sky, leaving behind its glowing contrail, a fleeting yet mesmerizing sight. So what exactly is a sounding rocket? These are specialized spacecraft designed for short-duration missions into suborbital space. Unlike their towering counterparts, such as SpaceX's iconic Falcon 9, which stands at an impressive 230 feet tall, sounding rockets are much smaller. They typically range from just 16 to 70 feet in height. For example, the Black Brant IX model set to launch from New Mexico measures nearly 60 feet tall. Their compact size makes them ideal for quick jaunts into specific regions of space that are too low for satellites but still scientifically valuable. Plus, because they don't require the massive boosters needed for orbital flights, these missions come with significantly lower costs, a crucial advantage in today's budget-conscious era of space research. But why choose New Mexico over traditional launch sites like Florida or California? While states like Florida and Texas dominate headlines due to frequent rocket launches, New Mexico provides a quieter, more remote setting suited for specialized studies. The vast, open deserts surrounding White Sands offer ample room for safe landings after the mission concludes. In fact, once the sounding rocket completes its journey, it will parachute back down within 70 to 80 miles of the launch pad, ensuring minimal risk to populated areas. This upcoming mission isn't just another routine flight. It has a very specific goal. The Black Brant IX will carry cutting-edge technology aimed at unraveling mysteries of the Sun's chromosphere. Sandwiched between the Sun's visible surface, the photosphere, and its outermost layer, the corona, the chromosphere plays a critical role in solar activity. It's here that energy conversion occurs, fueling explosive phenomena like solar flares and coronal mass ejections, events capable of disrupting satellite communications and power grids on Earth. NASA's Solar Next Generation Imaging Fabry-Perot Spectrometer, SNIFS, mission represents a first-of-its-kind approach. By combining a standard imaging system with a spectrograph, an instrument that breaks light into its component wavelengths, scientists hope to uncover new insights about the elements present in the chromosphere and how energy flows through this enigmatic region. This dual capability allows researchers to both photograph and analyze the light emitted by the Sun, providing unprecedented clarity into its inner workings. The entire mission will last no longer than 15 minutes, making every second count. After liftoff, the rocket will ascend to space in about 90 seconds, spend roughly 8 minutes conducting experiments on the chromosphere, and then return to Earth within 5 minutes. Despite its brevity, this mission could yield data that helps us better predict and prepare for space weather events, potentially saving billions in damages caused by solar storms. And this is the part most people miss. While crewed missions to the International Space Station or SpaceX's colossal Starship tests grab all the attention, it's these small-scale, focused efforts that often lead to groundbreaking discoveries. Sounding rockets might not have the same glamour as their larger cousins, but their contributions are no less vital. As we look toward the future of space exploration, one question lingers. Are we underestimating the importance of smaller missions in favor of headline-grabbing spectacles? Share your thoughts in the comments below. Do you think sounding rockets deserve more recognition for their role in advancing science? NASA rocket launch sparks solar science study at White Sands. Imagine the ground trembling beneath you as a rocket, the embodiment of human curiosity and ingenuity, soars into the heavens from the desolate expanse of White Sands Missile Range. This was no ordinary launch. This was a voyage to the very edge of our atmosphere, a mission to unravel the mysteries of our closest star, the Sun. But here's where it gets controversial. The Sun, a seemingly distant and unchanging presence in our sky, is actually a volatile, dynamic entity that impacts our very existence on Earth. The rocket carried a revolutionary new instrument, designed to study the Sun's surface and its effects on Earth, a field of study known as space weather. It's not just about understanding the stars, it's about safeguarding our technology, our very way of life. Professor Philip Chamberlain, the driving force behind this mission, described the journey to launch as a roller coaster of emotions, a sentiment that resonates with the passion and dedication of his team. For 5 long years, they toiled to create a groundbreaking tool to investigate the Sun's eruptions, the colossal explosions that send shockwaves through the solar system. This space weather isn't just a fascinating scientific concept, it directly affects our daily lives, influencing the atmosphere and the density of our upper atmosphere. It can disrupt GPS signals, affecting everything from navigation to emergency services. The launch was a moment of triumph for Vicky Hurd, who started as a graduate student on this project and now holds a degree, eager to delve into the data that will help predict solar flares, those powerful bursts of radiation that can wreak havoc on our technology. For Mitchell Horst, a spectator at the launch, it was a moment of awe, witnessing the culmination of years of hard work transitioning from a lab to the vast expanse of space. The analysis of this mission's data could take months, if not years, to fully understand. But for the military, the mission is ongoing. The White Sands Missile Range, a symbol of American innovation, continues to push the boundaries of science and technology, fostering a unique partnership between NASA, the Navy, and the U.S. Army. And this is the part most people miss. The potential for controversy lies in the interpretation of our findings. Are we truly prepared for the implications of understanding the Sun's capricious nature? What will we do with this knowledge, and how will it shape our future? The answers to these questions are as vast as the cosmos itself, waiting to be discovered. What do you think? Share your thoughts in the comments below.